let's take a look at another example using compound interest. How much should you invest now at 8% compounding quarterly to have $10,000 towards the purchase of a new car in 5 years? So first off, based on the question, how much should we invest now? That tells us we're trying to solve for P. So let's go ahead and list out our different variables. We have A, P, R. Since we have compound interest, we also have N, and then we have time. Let's see. So how much should you invest now? So the principal is unknown. We have 8% compounding quarterly. So interest rate is going to be 0.08. And since we're compounding quarterly, that means that our compounding frequency is 4. There are 4 compounding periods in 1 year. Let's see. We want to have $10,000. So the future value is $10,000. And we would like to have that $10,000 in 5 years. So time is going to be 5. So we'll go ahead and set up our equation. This time we're going to solve for P though. So we have A, so 10,000 equals P times the quantity, 1 plus the interest rate, 0.08 divided by the compounding period, which is 4. And that whole quantity is raised to the 4 times 5 because we have 4 compounding periods and we're going to go for 5 years. So we have 10,000 equals P times, be careful with the order of operations, 0.08 divided by 4 is 0.02, so we end up with 1.02 raised to the 20th. And you know, you can kind of clean things up before you jump straight to putting it in your calculator. So like at this point I wouldn't have put anything in the calculator yet. I would just have this, written on my paper, and then this is a very simple thing I can plug in the calculator. So now I need 10,000 divided by 1.02 raised to the 20, and we end up with $6,729.72. And again, we round up when we're solving for the principal, round up to the next penny. Okay, so we have $6,729.72. That's kind of nice, right? You can double your money essentially, right? Well, not quite double because this is more than 5,000, but you could almost double your money in 5 years if you have 8% compounding quarterly. So this is a nice way. If you have, if you have $6,729 sitting aside, you can find an account to give you 8% compounding quarterly. If you can let that money sit for 5 years, then it will grow, and then you can go ahead and use that for the down payment on your car. So it's kind of nice. The hard thing though is usually an interest rate won't be quite that high, so it'll be smaller. Let's take a look at one more example here. So what is the interest rate compounded monthly that would be needed for an investment of $5,000 to double over 2 years? So this is what we call a doubling problem. You can do doubling problems, you can do tripling problems, any sort of multiple. It doesn't matter how much we invest. So we're going to see that knowing this $5,000 isn't actually going to be important. So let's write down what we know and what we're looking for. R, N, N, T. So we know the principal is $5,000, and so that means that the future value, since we want it to double, then that would be 2 times our principal. And so this would be $10,000. But notice that we could figure out, so if I don't know what my principal is, I still know what my future value is. It's 2 times that principal. So you can do some things here when you're talking about doubling or tripling, even if you don't know what the initial investment is. The interest rate, that's what we're trying to find, right? What interest rate is going to do this for us if it's compounding monthly? So monthly tells us that N is 12 and the time is 2 years. So just looking at this right now, we want to double $5,000 in 2 years. This interest rate is going to have to be crazy high. Like, this is completely unrealistic for something that you could get from a bank. But we can go ahead and do this, and mathematically find the interest rate. but this is going to be really high, right? You shouldn't expect to double your money in 2 years just by putting it into an account because the interest rate's going to have to be really, really high. So let's see. Our equation, our future value formula, we have A, so that was 10,000 equals P, which is 5,000, times 1 plus R, which is unknown, divided by 12, raised to the 12 times 2. Okay? So R is what we're trying to solve for. Here's R. The tricky thing, though, is that it's inside of an exponent, so we're going to have to remember how do we break apart an exponent. And then we also are going to need to get rid of this 5,000 to begin with. So let's go ahead and divide by 5,000 on both sides. And look what happens on the left-hand side. 10,000 divided by 5,000 is 2. 2 is going to give us 1 plus R over 12 raised to the 24. Now the reason I'm so excited about this 2, on the other hand, what if I hadn't given you the $5,000 in the original problem? So I say, what interest rate, compounding monthly, is needed for an investment to double over 2 years? Well, we could still figure this out. If I don't know the original principal, so we just leave it as P, then the future value is 2P. And so if we have P on the right-hand side and 2P on the left-hand side, when we divide by P, we will always be left with 2 on the left-hand side. So you can answer this problem even if you don't know what the amount being invested is, because the important thing is not how much is being invested, but how much you want it to grow. We want this to double, and so we're going to end up with a factor of 2 on the left. If we wanted it to triple, then we would get a 3 on the left. Okay? So that's kind of cool. You can answer this question even if you don't know what that initial investment is, because it doesn't depend on the initial investment. Because the initial investment, the 5,000, just divided out, right? Everything we were left with was just the fact that we were doubling it, and so that gave us the 2. So that's kind of interesting. And that should seem reasonable. If we're trying to double our investment, well, here's my investment, 5,000, and then that means that this number must come out to be 2, because I need to double my investment. So that's kind of neat. So let's go ahead and continue from here. Let's see. We need to get to R, and we can't just like distribute the exponent, because you can't distribute exponents. Exponents are repeated multiplication. So really what we need to do like a 24th root. But there is no 24th root on your calculator, but a root is equivalent to an exponent of a fraction. So let's raise both sides of our equation to the 1 over 24 power. And that's equivalent to taking the 24th root. But this is something you can put in your calculator, whereas a 24th root might take a bit more work to get in your calculator. So taking the 24th root, we have 2 to the 1 over 24 is going to equal 1 plus R over 12, because the two exponents multiplied to just become 1. So now we have a simpler looking equation. We can subtract 1 on both sides. So we have 2 to the 1 over 24 minus 1 is going to equal R over 12. And now if we multiply both sides by 12, we'll be able to solve for R. So 2 to the power of 1 over 24, and then minus 1, and then we want to multiply that by 12, and this is going to equal R. The reason that I'm not putting decimals in here yet, right, I haven't used my calculator once yet, and that's because if you round at the beginning of the problem, and then you keep rounding as you go through the problem, then your decimal could become very off from where it needs to be. So you want to wait until the end to start using decimals, if you can, and you want to not round anything until you get to the final answer. So in my calculator, I'm going to do 2 to the 1 over 24, and then I'm going to keep that number in there, and then I'm going to subtract 1. So then I'll keep that number, and then I'll multiply it by 12, and that will give me what my R is. And so R comes out to, as a decimal now, 0.3 0.351626, and it keeps going. So our interest rate would be, remember we said it was going to be high? 35.16%. That's crazy high. You would never find a bank to give you 35.16% on an account. Okay? But this is the interest rate that we would need in order to double an investment over 2 years. Okay? All right. So we saw some interesting things in this example, and I hope it sort of illustrated that relationship for you. That's all for now. Until next time.